So I've already talked about these two special exponential growth and decay equation, right? And then we've already defined all these terms, so I don't need to recap this. But all what I want to remember to remind you guys that D is your doubling. And then H is your half-life time. Okay? Remember that they have to be the T and the D and the T and the H. They always have to be the same unit. So if one is in month, then the other one has to be in month. If your D is in days, then your T has to be in days. Okay? Always you have to match the unit for T and D. So instead of doing that trial and error, because it could take us forever plus to do that trial and error, okay? It took us a good 3-4 minutes to do that. I could do it in less than 30 seconds if I have the formula. So again, this is not part of your curriculum, but it will be helpful to know. So I want you to take your calculators out and to look for the button that says LOG, log. Do you see it? Can you locate that? Okay. Log is the opposite operation, is opposite to exponent. Okay? So, you know how square root and square, they're opposite? You know how multiplication and division, they're opposite? The opposite of exponent is log. Okay? So, if I want to solve, the formula says that if you have y equals a to the power of x and you want to solve for x, then what you need to do, you need to do the log of your answer divided by the log of your base. Okay? So, for example, if I have 7 equal to 3 to the power of x, okay? To solve for x, I do log of 7 over log of 3, and that would give me what my x is without doing any trial and error, okay? So, and it will give it to me to the nearest decimal. So if I do log of 7, so you press the log button, you do your 7, you write 7, make sure you close the bracket if it already opened the bracket for you. Divide by log of 3. Close bracket, and that should give you an answer of 1.77. If you did not get that, call me so I can come and help you with this. Okay? So the formula says you're going to do the log of your answer divided by the log of your base. Make sure that you do that. Try it. If it doesn't work, anyone else? Okay. No, you don't have to put the bracket. It doesn't work. Log 7. Yep. Okay. So what would be my formula for this next question? So 5 equals 1.06 to the power of x. Again, you can sit down and do the trial and error if you like. I'm okay with that. All right? But do you want to use the log? Let's use the log. What would we do?
Log 5.
Log of 5 divided by log of 1.06. That equals to my x. What's the answer?
27.6.
How about your next question? What do I do?
Log 25 over log 0.92.
So log 25 over log of,
0.97.
and what is that equal to? So you have to be careful here, guys, that when you do this, it's going to equal to your exponent, whatever your exponent is. In this case, my exponent is 2x. Okay? Now what do I do? So let's find the answer first. Log of 25 divided by log of 0.97. It's going to be minus 0.7. Okay? Something that's going to happen every single time you do log, eyes on me. If your log is less than 1, if you're logging something less than 1, your answer is going to be negative. Okay? So I have a positive over a negative. My answer is going to be negative. Now I have to divide by 2 because I want to isolate for that x.
It's going to be 52.8.
52 point. How about for C? So, log of, don't tell me the same. Log of 120 divided by log of 0.97.
Negative 157.18. And then multiply.
Then multiply by 3. Right?
Yes.
And what do you get there? 471? So anytime, if you don't have decimals, try to do the common base. But in this case, because I have decimal, it's hard for me to find a common base. I can use the logarithm to solve for it. Okay? Does that make sense to you? So if you had, let's say, 32 equals to 2 to the power of 7, or to the power of x, sorry, I'm expecting you to find common base. Right? If it's something like this, you can just use the log formula. Okay.
Sorry, Mike, can you go back?
What? Oh, I'll go back to it when I'm done. The last one. I can't waste anymore. Okay, let's go, please. Because I'm recording and just annoying for this whoever's watching.
Okay.
Okay. So caffeine has a half-life of approximately 5 hours. Suppose you drink a cup of coffee that contains 200 milligrams milligrams of caffeine. How long will it take until there is less than 10 milligrams of caffeine left in your bloodstream? So what formula do I use here? The half-life. So I'm going to start by writing out the formula. What am I given? What do I know? What is it? What letter is it? H is equal to what? 5 hours. Okay? What else do I know? So suppose you drink a cup of coffee that contains 200 milligrams of caffeine. What does this 200 represent?
Initial.
That's your initial. So that's A0. Okay? How long will it take until there is less than 10 milligrams of caffeine left? We're going to have to find T. What else do I know? So you know A is 10. Okay, now I'm going to plug in the given information to the formula. So A is 10. A0 is 200. Or A naught. And then don't know what T is. I know that my half-life is 5. What would you want to do? Divide by 200. Guys, this is a very important step. You have to isolate first before you can do anything. So the first step, you're going to have to divide by 200. Which is 0.05. Now, what do you want to do? I have to do a log, right? Because right now, all what I have is my bases. Okay, so log of what? 0.05 divided by log of 0.5 equals to what? T over 5. So what did you get when you do log 0.05? Okay? And then multiply by 5. $22. Okay? So what does that mean? So it takes 20, almost about 22 hours, right? To have 20 or 10 milligram of caffeine left in your body. So if you drink a cup of coffee that contains 200 milligrams, it's going to take 22 hours to reduce it down to 10 milligrams. Okay, so I don't get rid of the caffeine in my body at all. I'll get back to this 1 second.